Hello. So now I'm gonna show you my thesis. Um, I'll do a little demonstration about how to start up the whole setup and how to work with the DSpace control desk. I'm gonna show it to you now. Okay, so firstly we start up the DSpace control desk. There will be some errors. This is due to the loss of internet connection. We can ignore those. So it's starting up. Okay, firstly we open the model. So this is called motor model maximum position. Yes, we open it. Then the next step is to open the layout. This is called ball controlling. We open it. Yes, we want them to be loaded. We can change the length of the simulation. I'll put it on 20. The maximum length is 25 seconds. If you make it longer, the model will be too heavy and it won't be able to start up. So if everything is set up now, so we can start the power supply of the motor, and we run the simulation and we go to full screen. So now I can start turning the wheel. As you can see, the ball starts to move, the angle starts to move, and yes. Well, first you can see this is the in this screen you can see the measured angle and the angle of the beam in the simulation. It's green and red. The red one is measured. As you can see, the green one is almost always covering the red one, as it should be. Here you can see the beam angle velocity. That's the velocity of the angle of the beam. The ball position, now it's placed at now it's positioned at minus 0.5. That means that's at one end of the beam. This is the velocity of the ball. Here you can see the torque feedback. This torque feedback is the feedback that is calculated. This is a real feedback without boundaries, so you can always see how much it should be. And this is the feedback current. This is the feedback that is measured again from the motor, that measures the real current, and this is limited due to the motor restrictions, because the maximum torque of the motor. So okay, if I start to turn now, you can see the angle is changing and the ball comes loose of the one end of the beam and goes to the other end, and it bounces against it. And that's one implemented thing. And if I move again, it goes back. And if I move fast from one side to the other, you can see it's always bouncing very fast. Okay, and now I'll try to balance the ball to somewhat the middle. So now I passed the 0, so it comes loose, and you can see, and it goes. It's requires some practice to make the ball balance perfectly, but this is also the same for real systems, so you can't blame the haptic device for that. It's a very unstable system, the ball beam system. And now I'm somewhat in the middle. Okay, and this was then the demonstration of the ball beam of my thesis. Thank you.